Alright, these are our notes for day 2 on section 6.2, simplifying rational expressions. So here's the warm-up we did in class. You can pause the video if you want to try the warm-up. I'm going to show the answers here in a few moments. So when you're ready, start the video back up. Here are the answers to the warm-up. Alright, here are the homework answers. The ones circled with problems that people asked about in class today. So I showed the work. So check your homework. Here again, you can pause the video if you need more time. Alright, here's the rest of the homework answers. Again, the ones that were circled, the ones that people had questions about. Alright, this is a practice that we did in class. So this is from the day 1, 6.2. This is what I expect you to be able to do from day 2, on day 1 on section 6.2. If you get a paper copy of the notes, it's on the back of the notes or where these problems came from. So try these and then check your answers using the video. Alright, let's start with our examples for today. We want to write radicals in simplest form. Alright, what you have to remember that no radicals are allowed in the denominator. So what we're going to try to do is make the denominator have a whole number exponent by rationalizing, similar to what you did in geometry. Okay, so the first thing I always do is change it to a rational expression. Go rational before you go radical. So we're going to rewrite 64 as 2 to the 6th power. So this becomes 1 over 2 to the 6/5. Now this step here, this is where I'm rationalizing. This is the work that I need to consider doing. So what do I want? So I've got 6/5. So I want to make the next whole number to 6/5 is 2. So that means I want to get in my denominator an exponent of 10/5, because 10/5 divides to 2, and that's a whole number. So what do I need? What do I need to multiply 2 to the 6/5 by to get 2 to the 10/5? Now remember, you're adding your exponents. So 6 plus 4 is 10. That's why I multiplied by 2 to the 4/5 over 2 to the 4/5. Now this is another expression for 1. That equals 1. That's called rationalizing. Alright, let's simplify this. So my numerator, I'm going to get 2 to the 4/5. And on my denominator, I'm adding my exponents. I'm going to get 2 to the 10/5. Alright, we want to write this, change this back to a radical. Since 4/5 is less than 1, that means that's as simplified as I can get it. So I'm going to rewrite it back as a radical. So the 5th root of 2 to the 4th over 2 squared. And now just evaluate those expressions. So the 5th root of 16, because 2 to the 4th is 16, over 2 squared, which is 4. So this is my final answer. Alright, let's try another one. Alright, change it, go to rational before we go radical. Alright, so let's change it to rational expressions. So 3 to the 1/3, that's easy. 4 can be rewritten as 2 squared. Okay, so now when I raise that to the 1/3 power, I'm going to get 2 to the 2/3 power. The closest whole number to 2/3 is 1. So this is my goal. I want to get 2 to the 3/3. So what do I need? I need 1/3. So I'm going to multiply by 2 to the 1/3 over 2 to the 1/3. This is my rationalizing step. Alright, let's simplify it. So here you keep what's the same. So I'm going to keep the 1/3, and I'm going to do math to what's different. So 3 times 2 is 6. And on the bottom, keep the 2, add the exponents, 3/3. Change it back to a radical. So the 3rd root of 3, cube root of 6, and 2 to the 3 over 3 is 2 to the 1st, which is just 2. Alright, so we're not allowed to have any radicals in the denominator. Alright, let's look at example 6. Your note's out of order, so find example 6. we're going to add or subtract like radicals. Now here we must have the same variables and the same radicals in order to be able to add the coefficients. The variable parts and the radicals have to be exactly the same. Coefficients can be different. Okay, so we need to simplify the cube root of 24. So what is the largest cube root, largest perfect cube in 24? So we're going to rewrite as the cube root of 8 times 3. So the cube root of 8 is 2. And of course the cube root of 3 I can't simplify anymore. And then 4 cube root of 3 was already simplified. So now I add the coefficients, keep the exponents. Since these parts are exactly alike, you keep what's alike, do math to what's different. So our final answer is 6 cube root of 3. Alright, same process with a square root. So 32, the largest perfect square in 32 is 16. So I'm going to rewrite this as the square root of 16 times 2. Square root of 72, the largest perfect square in 72 is 36, so this is 36 times 2. The square root of 16 is 4, so this simplifies to 4 square root of 2. And the square root of 36 is 6. So this becomes negative 6 square root of 2. Alright, so now my radicals. Alright, so now I'm going to combine my coefficients. So 4 minus 6 is negative 2 square root of 2. Alright, more examples. Notice here that 3x to the 2/5 power and 3x to the 2/5 power, they're already alike. So now I just get to combine the coefficients. So 5 minus 8. Alright, so I'm going to go 5 minus 8, which is negative 3. I'm keeping the rational part, the 3x to the 2/5. Alright, now if it asks us to change it back to a radical, we're going to change the 3x to the 2/5 powers back to a radical. So the 5th root of 3 squared, x squared. Well, 3 squared is 9, so this is my final answer, back in radical form. Alright, here's when we have some work to do. Because these are different, I can't do anything with them yet. I got to see if I can simplify them to make them have the same radical part. Okay, square root. Square root of 16 is 4. That's where the 4 is coming from. The square root of x to the 3rd. How many pairs of 2 do you have? How many groups of 2 do you have in 3? You have 1. That's where this x is coming from. This x squared was already outside. And you have 1 left over. Alright, let's do the x to the 7th. Alright, x to the 7th. How many groups of 2 do we have in 7? There are 3 groups of 2, so it's x to the 3rd power gets to come out with 1 left over. Alright, so now x squared times x is x to the 3rd. So now my variable part looks exactly the same. So subtract the coefficients, 4 minus 2 is 2, and you keep the variable part, x to the cube root of x. No, take that back. It's x cubed square root of x. So be careful, make sure that that looks like an exponent, not an index. So you might want to leave a little bit more space than I did. Okay, look at 24. So the first part of this, I want to raise everything to the 1/3 power. So I'm going to get x to the 9/3, y to the 1/3, plus, second part of this, I'm going to cube everything inside the parentheses. So x to the 3rd, y to the 3/9. Simplify what we can. 9/3 becomes 3. So I get x to the 3rd, y to the 1/3, plus x to the 3rd, y to the 1/3. Now this part is exactly the same. Alright, remember there's a 1 out front, so add the coefficients. 1 plus 1 is 2. X to the 3rd, y to the 1/3. Change it back to a radical. So our final answer is 2x to the 3rd times the cube root of y. Alright, example 7, we didn't have time to finish them all in class, so we just did 23 and 24. It's just putting them all together, putting all the properties together. So first thing I do is rewrite this as a rational expression. So this is step 1. So it becomes a to the 2/3 over b to the 1/3. Now, since I've got a radical in the denominator, I need to rationalize this. Oh my God. So that means I want to get the closest whole number to 1/3 is 3/3. So I'm going to rationalize by multiplying by b to the 2/3, numerator and denominator. So my numerator, I get a to the 2/3, b to the 2/3 over b to the 3/3. Alright, let's change it back to a radical. Since these are less than 1, nobody gets to leave the radical, so that means we get the cube root of a squared b squared all over b. Alright, example 24. Alright, simplify the interior of this first. So 64 can be rewritten as 2 to the 6th power. I'm going to subtract my exponents. That's where I get x 10 minus 5x, x to the 5th. And I'm going to subtract my exponents from my y. 3 minus 1 is 2. All raised to the 1/5 power. Alright, so raise everything to the 1/5 power. We get 2 to the 6/5, x to the 5/5, over y to the 2/5. Alright, so that means I'm going to have to rationalize. Here's my rationalize step. The closest whole number to 2/5 is 1, 5 over 5. So that means I'm going to multiply by y to the 3/5, my numerator and my denominator. Okay, let's start simplifying stuff. Because this is 6/5, that means when I go back to simplify it, I'm going to have a 2 that gets to leave the radical. Here's my math. Alright, x to the 5/5 is 1, so that means that's on the outside. I have a 2 left over. That's why I have a 2 on the inside of my radical. And y to the 3rd, this is less than 1, so that means the y to the 3rd stays on the inside. And then on the denominator, I have y to the 5/5. So my final answer is the bottom. Alright, the homework for this is 4D. So try it and see if you have any questions.